Welcome back, everybody, to Science Corner. We've got a really cool deep dive lined up for you today. We're going to be talking about the Oomplet Dataset Toolkit.
Yeah, really exciting stuff.
Yeah, it is. For anyone who's new to this, the Oomplet Dataset Toolkit, or ODT, is basically like this powerful engine for generating millions of these unique cartoon-like humanoid figures. We're talking like customizable, candy-colored characters. Each one is a unique individual.
Yeah, like imagine a digital artist's studio,
Mm-hmm.
except instead of one artist, the studio can pump out, millions of these little guys. Each one slightly different thanks to this clever algorithm.
Millions. That's a lot of digital candy people. What's so groundbreaking about having access to so many of these Oomplets? What can researchers actually do with them?
Well, for decades, scientists who study visual learning have used computer-generated images to understand how our brains, perceive and categorize things. But the early data sets, even the ones with the famous greebles, those kind of weird little creatures they used to study object recognition,
Oh, yeah.
they were pretty limited in size and scope.
So even though those early studies were really important, they were working with a pretty small sample size, relatively speaking.
Exactly. And creating those images and organizing them into categories was very, manual and time-consuming. So that's where the ODT really shines. It blows those limitations out of the water by offering millions of stimuli and a flexible system for categorizing them.
Okay, I'm starting to see why this toolkit is such a big deal. So how exactly does it work? How do you go from 0 to 1,000,000 Oomplets?
It's all thanks to the component-based design. So imagine you have a digital Mr. Potato Head, right?
Yeah.
But instead of just a few parts, you have 7 classes of components, think body parts, and each component can have up to 10 different attributes.
So you're talking about things like the shape of the head, the color of the eyes, whether it has eyelashes or not.
Precisely.
Yeah.
You can control all those features and more. The real magic happens when a script called generate.py picks one file at random from each component directory and assembles them, kind of like a digital jigsaw puzzle.
So it's like reaching into a bag of arms, a bag of eyes, a bag of noses, and pulling one at random from each bag to build your Oomplets.
That's a great way to put it. And to make sure it all comes together seamlessly, there's this clever use of OpenCV, which is like an image processing library to kind of stitch all the pieces together into a finished image.
It sounds like a fascinating blend of creativity and coding. But with millions of these unique Oomplets running around, how do researchers even begin to make sense of them all? How do they organize them for their experiments?
That's where another clever script comes in. It's called categorize.py. This script acts like a filter, sorting Oomplets based on any criteria the researchers, can dream up.
So if I wanted a category of, say, all Oomplets with square heads, purple bodies, and 3 eyes, the script could find them for me in this vast digital sea of Oomplets.
Exactly. It's that powerful and flexible. So researchers can create any category they need to test their hypotheses about visual learning. So, you want to study how people learn to distinguish between Oomplets based on color alone. Easy. Want to create, complex categories based on combinations of features like shape and texture? No problem. The possibilities are pretty much endless.
Yeah.
And that's what makes the ODT such a, leap forward in visual learning research. It's not just about having, a ton of images. It's about the level of control and flexibility that researchers have when they're designing their experiments. So they can actually test these really specific hypotheses about how the brain processes visual information in ways that just, weren't possible before.
That makes a lot of sense. It's like having a super-powered microscope for the mind. But how do we know that these Oomplets, as cute as they are actually a reliable way to study human perception? Have researchers put them to the test?
Oh, absolutely. They conducted this validation study to make sure that the ODT was, scientifically sound. The study focused on 8 key attributes of the Oomplets, like things like shape, color, the size of their eyes, length of their limbs, and so on.
So they put these Oomplets through a battery of tests to see what features really stood out to human observers. It's like an Oomplet obstacle course for the brain.
Exactly. And they used this method to measure how easy it was to distinguish between the different features. It's called the D prime score.
Okay, for those of us who aren't, statistics whizzes, could you break down what a D prime score actually tells us?
Okay, so think of it this way. Imagine you're trying to hear your friend whispering a secret in a really crowded room. If the secret is loud and clear, easy to pick out from the background noise, that's like a high D prime score. But if the secret is barely audible, lost in all the chatter, that's like a low D prime score.
So the higher the D prime score, the easier it is to tell the difference between two things. whether it's whispers in a crowd or different features on an Oomplet.
Precisely. And in the ODT validation study, some features really shined while others, kind of faded into the background.
So which Oomplet features were the rock stars, the ones that got those high D prime scores?
Shape and color were the clear winners. People could easily tell the difference between Oomplets with, sharp angular bodies versus those with smooth rounded shapes. Color was another, slam dunk. Yeah. Distinguishing between cool blues and greens versus warm reds and yellows was a breeze.
So bold shapes and vibrant colors are like the attention-grabbing billboards of the Oomplet world. They just pop. But I'm curious about the features that didn't fare so well. What were the Oomplet characteristics that had people scratching their heads?
Well, eye distance was a bit of a stumper. Turns out we're not so great at picking up on subtle variations in how close together or far apart an Oomplet's eyes are. Leg length also proved to be, a bit tricky.
So even though some Oomplets might be sporting these, long, lanky legs while others have short, stubby ones, those differences didn't exactly jump out at people.
That's right. And this is where it gets really interesting because it starts to tell us something really fundamental about how our brains prioritize certain visual cues over others. We're kind of wired to pay attention to things like shape and color, probably because those features were evolutionarily important for survival.
Yeah, that makes sense. Being able to, quickly spot a predator lurking in the shadows or a ripe piece of fruit against a green background would have given our ancestors a leg up. But subtler features, like the exact distance between someone's eyes, might not have been as crucial for survival.
Exactly. And the ODT allows researchers to test these ideas about visual perception in this, really controlled way. So by tweaking the features of the Oomplets and measuring how well people can distinguish between them, they can start to build this really detailed map of how our brains prioritize these different visual cues.
It's amazing to think that these cute little cartoon characters are actually giving us a window into the inner workings of the human mind. But the ODT isn't just limited to studying human perception, right? I've heard it has some pretty interesting applications in the world of AI, artificial intelligence.
You're absolutely right. The ODT is proving to be incredibly valuable for training and testing AI systems. Imagine putting a human up against a computer in this, Oomplet identification challenge. By comparing how humans and AI learn to categorize these digital creatures, we can gain some, really fascinating insights into the differences between human and machine learning.
That sounds like a fascinating digital showdown. Who do you think would win, human intuition or AI processing power?
Oh, it's a tough call.
Yeah.
But that's what makes this research so exciting. We're on the frontier of understanding how AI systems perceive the world, and the ODT is giving us a really powerful tool to explore these questions.
It's incredible to think that these seemingly simple cartoon characters are playing such a, big role in cutting-edge AI research. But I have a feeling that the ODT's potential goes even beyond the lab. Could these Oomplets find their way into, our everyday lives?
They very well could. Imagine using Oomplets to create these engaging educational games for kids. They could learn about shapes and colors and patterns by, sorting and categorizing Oomplets in a fun, interactive way. And because the ODT is so flexible, you could tailor the difficulty of the game to match a child's, learning style and development.
It's amazing how these Oomplets can be both whimsical and scientifically valuable. It really speaks to the power of creativity and research. But before we get too carried away, brainstorming Oomplet-themed video games, let's go back to the validation study for a moment. You mentioned that shape and color were the rock stars, but I'm curious about the, specifics. What were the D prime scores for these, superstar features? And what about those features that were harder to distinguish? Can we, put some numbers to those observations?
All right, so let's get down to brass tacks here with these D prime scores. I'm really curious to see how those numbers actually, flesh out the results of this validation study.
Sure. Well, for shape and color, the D prime scores were, significantly above 0, which in statistical terms basically means that people were really good at telling those features apart.
So they aced the shape and color tests, no problem there. But what kind of numbers are we talking about here? To give our listeners, a sense of the scale. Well, for shape, the D prime score hovered around 2.5. And for color, it was even higher, closer to 3.0. So these are, very robust scores, indicating really strong discriminability.
Wow. Those are some impressive scores. It really highlights how our brains are wired to notice those features right away. They're like the visual equivalent of a loud siren.
Exactly. Now, on the flip side, The features that people, struggled with, like eye distance and leg length, had D prime scores very close to zero.
Oh, interesting. So those like subtle variations just didn't register as strongly. It's just fascinating how our brains have these like built-in preferences for certain visual cues over others.
Yeah, it is. And this kind of knowledge is so valuable for researchers because they can use the ODT to, really fine tune the difficulty of their experiments.
Hmm.
So they want to create a super challenging task. They can use those subtle features with the low D prime scores.
Hmm.
But if they need something more straightforward, then shape and color are the way to go.
It's like having a visual learning dial that you can adjust to match your research question. Pretty ingenious.
Absolutely. And, remember, this is just the beginning. We're still uncovering all the amazing ways that the ODT can be used to understand visual learning. It's like Pandora's a box of possibilities.
I'm already excited to see what the future holds for Oomplet research, from, training AI to designing educational games. The potential is truly mind-boggling. Who knew these little candy-colored characters could be so impactful?
It really is a testament to the power of, interdisciplinary research. Combining creativity with, scientific rigor can lead to some truly remarkable breakthroughs.
Well said. And on that note, I think we've thoroughly explored the world of Oomplets today. We've covered their creation, their validation, and, their vast potential applications. What a journey.
It's been a pleasure diving into this fascinating topic with you.
Likewise. And to our listeners, we hope this deep dive has sparked your curiosity about the science of visual learning. If you could design an experiment using Oomplets, what would you study? Share your ideas with us on social media. We'd love to hear your thoughts. Until next time, keep exploring the world with those curious minds of yours.